All right, let me ask you something. Have you ever found that perfect piece of code, maybe an old library or a legacy system, that you really want to use but it just won't plug into your new project? It's like it speaks a completely different language. Well, today we're going to dive into the design pattern that solves this exact problem. And trust me, this is a big one for any technical interview. We're talking about the adapter pattern.
So, picture this. It's the classic scenario, right? On one side, you've got this valuable old code. On the other, this shiny new system you're building. They have to connect, but their interfaces, the way they're supposed to talk to each other, are just totally incompatible. So what do? Do you rewrite all that old code? No way. Instead, you bring in an adapter to act as a translator, and just like that, they can work together seamlessly.
Okay, before we get into the solution, let's really dig into the core problem here. Because at its heart, it's all about a fundamental mismatch. Let's make this super concrete, okay? Imagine our new client system, let's call it System A. It expects to call a method named print. Simple enough. But the super valuable component we want to reuse, System B, well, it does the exact same thing, but its method is called print old. See, they're speaking different languages. And here's the really important part, the key constraint. We can't, or, really shouldn't, change the source code for System B. So what do you do?
And you know what's so cool about this? This software problem has a perfect real-world equivalent, one that I guarantee you've used before. I think the absolute best way to really get this pattern is to look at a simple, everyday object. Yep, it's that simple travel plug adapter. You know that little device you throw in your suitcase? It is the perfect physical model for what we're trying to do in our code. I mean, think about it. You land in a new country, you've got your laptop, and it has one type of plug. But the wall socket, it's completely different. The interfaces are incompatible. There's just no way to connect them directly. And that's exactly where the adapter comes in. It's the perfect middleman, right? It takes your device's plug on one side, and it fits perfectly into the wall's socket on the other. And here's the most important part. It doesn't change your laptop, and it doesn't change the wall socket. It's a totally non-invasive translator that just bridges the gap. And that is the core idea right there. The adapter pattern has one job and one job only: convert one interface into another so they can work together. It's the bridge. It's the translator. It lets you get compatibility without having to make messy and honestly risky changes to code that's already working. Okay, so with that travel adapter analogy locked in our minds, let's translate this directly into code and see how it actually works in practice.
So in the code, we basically have three key players. First up is the adaptee. You can think of this as our old incompatible code, kind of like the wall socket in a foreign country. Then we have the target. This is the interface our new system expects, like our laptop's plug. And finally, of course, there's the adapter itself, the magic piece of code that makes them talk to each other.
All right, so here's our adaptee, the old printer class. Just think of this as our legacy code. It's got the printing logic we want, which is great, but its method is named printold. And remember that rule we talked about, we cannot touch this file. It's off limits. Next up, we've got the target. In this case, it's the printer interface. The best way to think about an interface is like a contract. Our new system is designed to work with any object, no questions asked, as long as it signs this contract, which just means it has to have a method called print. That's the standard. And now for the brilliant part, the adapter itself. Okay, look closely at what it's doing here. First, it implements our printer interface. So as far as our new system is concerned, it looks like a perfectly valid printer. It's honoring the contract. But then, look inside its print method. It's holding a reference to our old printer, and it's secretly calling the print old method. It is the ultimate translator, connecting the new call to the old one. And this, right here, is the most critical takeaway of all. We made our old printer completely compatible with our new system, and we didn't have to change a single line of its original code. That is the true power of this pattern. It allows for non-invasive integration. Okay, so understanding the concept is one thing, but how do you talk about this in a technical interview and show that you really know your stuff? Let's get into the strategy. So when your interviewer inevitably asks, why is this pattern useful, you need to go beyond the basic definition. You want to tell them it's essential for three big reasons. First, it lets us reuse valuable legacy code without having to touch it. Second, it's an absolute lifesaver for integrating third-party libraries where we have zero control over their interfaces. And third, it helps us create a more loosely coupled system, which just means everything is more flexible and easier to maintain. Now, if you want to demonstrate some real senior-level thinking, you got to mention the trade-offs. You can point out that a common mistake is not using an adapter when you should, like when people just go in and modify old code, which is super risky. But you should also mention the flip side, overusing the pattern. Look, if you do control the source code and just renaming a method is an easy fix, that's probably a cleaner solution than adding a whole new class to your system.
And finally, every great interview answer needs a powerful, concise summary. So when they ask you for the one-liner, you need to have this ready to go. Here it is. The adapter pattern allows incompatible interfaces to work together by acting as a translator between them. It's clean, it's accurate, and it perfectly captures that translator idea. That single sentence shows you get the fundamental purpose of the pattern.
And there you have it, the adapter pattern. It's a simple, really elegant solution for getting new and old code to play nicely together. If you can master this concept, you're not just ready for an interview question, you're ready to build systems that are way more flexible and robust. Thanks for tuning in.